Since there are many articles talking about the confidential computing, so I would like to introduce this confidential computing architectures and also tell you why and how our path can be used in the confidential computing. So please turn to page 15. With the rise of IoT and AI applications, a tremendous amount of data are generated. The processing of this huge amount of data requires not only high-speed computing, but also secure computing, such that the sensitive data is safeguarded. The processing of data includes data at the rest, data in transit, and the data in use. And for the data at the rest and in transit, we can encrypt the data so that they cannot be compromised. However, for the data in use, such as the execution of a program code and its related instruction set, the data cannot be encrypted and need to be plain data for CPU to execute. So in the current computer systems, data in use are brought into virtual memory, which is shared by different applications and is therefore not protected. So this has been resulted in attacks on CPU, such as the meltdown and the Spectre attack on Intel's CPU, which was reported last year or the year before. And so to solve this kind of issues, confidential computing architecture is needed. So in the following slide, I will introduce what is the confidential computing. So please turn to page 16. So in this page, you can see that no confidential computing in traditional architecture is illustrated in figure 1. The CPU and the memory, they take care of the application. And since a single CPU can only run one application at a time, so in this case, the CPU will solely use the memory. And to improve the security of such structures, the CPU's security function can encrypt and manage the memory, as shown in figure 2. Please turn to page 17. However, as a CPU moves to multi-core structures, which can tackle many applications simultaneously, the architecture will evolve to the one shown in figure 3. The applications are divided into 2 sections. One is a secure section, and which will be operated in a trust ROM. And the other is non-secure sections. And in the trust ROM, the operation of the application happens inside the so-called security enclave, which means the data and the code are all protected by its security functions. But on the other hand, for the non-secure sections, data and the code are stored in the virtual memory, which is shared by many applications. So in page 18, as more applications are required to operate in the trust ROM, the dedicated memory, which was supposed to be solely used by its corresponding CPU, become inefficient. To improve such case, the secure applications will also need to use the virtual memory to increase its storage capacity and also flexibility, as shown in figure 4 on the left-hand side. In order to secure these applications by using virtual memory, the data and the code will be tagged for the specific applications such that other applications are not able to access them. Even if it can be accessed, the data is not meaningful since they are protect or encrypt. And so our path is needed for such functions, since it can efficiently scramble the data and the code, and also descramble using the same path numbers. But however, in those applications, the trust zone will still be isolated, and because those applications will be mainly used for the payment-related applications, so which is need to be much more secure. But the rest of the applications, which also need security, but they can use the memory taking technology to protect their program code and the data in the virtual memories. Okay, so in page 19, so how can our path help in the confidential computing architectures? So recently, like the new rise of DPU, which actually is used to unload the data storage and the security functions of the CPU. And the DPU is targeted at helping CPU's architecture move toward confidential computing. So we are working with some companies to implement our path into their security architectures. So by applying path to protect the data and the code in the virtual memory, path can enable the computing to become confidential computing, and can help protect all the devices of the internet and the cloud. So this concludes my introduction for the confidential computing.